on example 3, video 2. Again, I have my box and I have a force applied horizontally. So there's 20 newtons applied horizontally of an object at rest. The second force of 40 newtons is applied at 40 degrees from the horizontal. So somewhere about here looks like 40 newtons, and we'll call that a 40 degrees. And we want to determine the magnitude and direction of the resultant force. Well, if we go back to that parallelogram rule, I can do one of two things. I can either move the 40 newtons over here, or I can move the 20 newtons over here. So I'm going to show you both ways. Here's the 20 newtons that way. And over here, if I'm using the moving the 40 newtons, this would be the 40 degrees because this is 40 above horizontal. This angle in here would actually be 140. So something to be aware of, that 40 degrees from horizontal may not be the angle inside the parallelogram. It may be outside the parallelogram. And so what we're looking for here is the resultant, which would in either case would be that vector there. So if we look at this, we know that we have a side angle side amount of information in a triangle that's not a right triangle. So if we go back in our memory and think about this, we're looking to use the law of cosines here. And I'm going to use the 140 because that's the angle that's on the interior of this. And it would also be the angle up here if I wanted to use that one. You'll get the same answer either way. And so let me do a little simplifying here. And I get 2,000 minus 1,600 cosine 140. And let me get my calculator out to get that. So I have 1,600 cosine, make sure I'm in degrees, because that would give me a weird answer in radians. And of 140 gives me a negative, so 2,000 minus negative 1, 2, 2, 5, 6, 7. So I'm going to go 2,000 plus that number. And then I'm going to square root it. And I get a D of 56.79. So that would be the magnitude, because that's the distance of that. And our direction we need to find, and to do that I think we're going to need to use the law of sines. So to use the law of sines, we have, this is 140. We now know that we can, let's use the law that says, or the sign that says the sine of theta is to 40. So this angle in here, that's where I'm putting my theta. So that is to 40, as the sine of 140 is to this 56.79 that we have. And I'm going to pause it here to get that answer. So I did the cross products and then solve, and I got 26.92 degrees. So my direction is 26.9 from the horizontal. from the horizontal with a magnitude of 56.79. Oops. Oops. There we go. Let's take a look at this example. Put my calculator down. A 45 Newton force is applied to an object at 55 degrees. Determine the horizontal and vertical components of it. So here's what we got going on. Here's my box. I have this at 55 degrees from the horizontal. So there's a triangle that it makes. And we know that this is 45 newtons. And we know this is the opposite. We know this is the adjacent. And so I'm going to, my component form of this is going to be that r times the cosine, which is the adjacent over hypotenuse, and our sine theta. And so one is the horizontal movement, that's this one with the adjacent, and the sine is the vertical. And so we're going to find those two values, and on this one I get, would be 45 times the cosine of 55, comma, 45 sine 55, and typing those into my calculator, I got 25.8 and 36.9. We know that the first one is the x component, the second one is the y component. And let's take a look at this. Suppose that a heading for a plane is 100 degrees and the airspeed is 290. The wind is currently at 45 miles an hour at 190 degrees. Determine the ground speed and drift angle and the course of the airplane. All right, so I have this set up a little bit for us. We know that since we have north, we're going to be, this is 100 degrees, because when we have headings, we're going to measure them from the north, just like the pilots do in airplanes. So we know that that is going to be 100 degrees, which means that this is going to be 290 miles per hour. And the other one, we have a wind that is 45 miles per hour from 190 degrees. So let me grab a green one here so you see it. If I go around here, and there's my 190 degrees, the wind is from that vector. That means it's going to where I had the green one to start with. So if this is 10 degrees past 180, then this is going to be 10 degrees. So that makes this vector in here 90 degrees, or this angle in here 90 degrees, because 10 plus 90 gives me the 100 degrees. So then we have to start answering some questions here. Our heading is the direction the plane is pointed, measured clockwise from north. I'd use that. The course is where the plane actually goes. The airspeed is the speed that the plane is relative to the ground, relative to air. The ground speed is the speed the plane is relative to the ground. Drift is the angle from the heading to the course. And if plane velocity and wind when the magnitude is added together is ground speed and direction is course. So let's see if we can find a few of these things. What I want to do here is I want to put each of these vectors in component form and then add them together. So here's my plane is going to be 290 cosine of 100 degrees, 290 sine 100 degrees. And so if I put those in my calculator, I get the component form of the plane vector is negative 50.4 for easy math, and I get 285.6. So why is that first number negative, I ask myself. Well, if we look at this, we know that we're in the fourth quadrant. And in the fourth quadrant, we know that this thing is moving downward, and down is a negative direction. Now let's do the same thing for the wind. Get that in. Our wind, I'm going to go with 45 cosine, and the angle that it was given is 190. And 45 cosine sine, ooh, that's a sine of 190. And let me get those numbers. Well, when I got these two numbers, I got negative 44.3, negative 7.8. But we have to look at our picture. My 190 is where it's from. It's down here in the third quadrant, so both of them were negative. But the wind is blowing to the first quadrant. So even though we were given a 190 degree angle to start with, I know that the wind is in the first quadrant, so I have to make both of these positive. So sometimes we have to think through what's going on. Even though that 190 was given to us, it's actually blowing to 10 degrees from vertical. So that's why I made those positive. And so now if I add my plane plus my wind, I get negative 6.1 comma 293.4. So there's my resultant velocity. From that, I'm going to get my, let's draw this so you can see what's going on. Right there is my resultant. And so I want to get the resultant magnitude. So I'm going to use the distance formula on that. And I get square root of negative 6.1 squared plus 293.4 squared. And I'm going to have to pause again to get that magnitude. And I ended up with 293.5 miles per hour. And here's a neat outcome, which first looking at it, I didn't notice it. But if this is at 100 degrees and that's at 10 degrees, that's a right angle. And we could probably plug that into the Pythagorean theorem. And I did that, and I'll be darned if I got the same answer, the 193.5. So I might have done it a more difficult method. So if that's true, we want to know that the drift is going to be